Okay, so stem and leaf. They're going to give you a bunch of data and they ask you to draw a stem and leaf. Now, what they like is they like a back-to-back stem and leaf where they give you data for two different groups at the same time. The principle is the same. It's not a problem. All you're going to do is you're going to make a line with a ruler. They definitely care. And you're going to work out what you want to be the stem. So if you look at this data, it's the ages of 20 people. They start at sort of 21 and go up to, no, they start at 14 by the looks of things. And it looks like the oldest person is about 65. So it makes sense to make the stem look like this. In other words, we've got people in their teens, people in their 20s, people in their 30s, people in their 40s, people in their 50s, and people in the 60s. Now, you'll see quite often with a stem and leaf diagram that they start with the highest number, and they go 6 and they go down. It makes it more confusing. They'll accept either, and this one you're going to screw up less. So I would suggest you do it this way, right? I would not put them in order the first time. In other words, I'd do it twice, and you might think, oh, it's going to waste time, but you're going to get it right, as opposed to you trying to do everything at the same time and you get it wrong. So I'm just going to cross these off. I've got 25 there. I'm just going to put it there. I've got 21 there. I'm going to put it there, right? 65, I'm going to put there. 43. It's very easy to make mistakes with these, which is very unfortunate. There's another 43. 16, I'm going to put there. 21 can go there. 36 is going there. 28 is going there. 14, so tedious. There. There's 32 and 35, so 32, 35, 57, 22, 21, 44, 17. So you get the idea what's happening with the stem and the leaf. It's not the hardest concept. So that will get you exactly no marks. It has to be ordered, and they're fussy. You see how the numbers, they have to be spread out perfectly. They have to be well spread, and they have to be in perfect rows, which is why doing it twice is a good idea, because you can now focus on making it beautiful. So I'm going to redo it. 1, 2, 3, 4, 5, 6. I'm just going to squash it over here. Everything has to now be in order. So the smallest one first, that's going to be 4, and then 6 well spaced, and then 7. That one I'm going to change because it's 2 spaced. They have to be exactly the same spacing between them, and they have to be well spaced, or they don't give you the marks. They're fussy. The idea is that this is supposed to look like a bar chart on its side.
Can you do commas in between?
Can you do what?
Like commas or dots in between?
No commas, no dots. Good question.
So
They must just be the numbers.
Do you have to measure like as far as it goes one way and make sure?
You don't have to measure, but you do have to be careful. So they're not out to nail you, but actually maybe they are for this, because they really are fussy. So spread them out nicely. So I've got 2, 5, 6 for that one. And because now I've got less numbers, I can get them in order without making mistakes with any luck. There we go. So that is now an adequately good stem and leaf diagram. The point is, if you were to put it on its side, it looks like a bar chart. And because the things are spaced out equally, you can see that the modal group, the one with the most numbers, is the people in the 20s at a glance, right? Because imagine if you packed them all in an untidy manner, then you could look at it and you could say, oh, well, you might get the wrong impression. It's supposed to look like a bar chart. So everything has to be spaced out beautifully. In addition, you have to have a key. And the key is very unpleasant because they are very thorough. So this is the key. You write down key, and you say 2-1. So take something from your table. Means age 21 years. You have to do that, or you lose a mark for your key. Not only the key has to say, it has to show some piece of the diagram itself. So don't make something up. Don't make up somebody who's 68. There's nobody who's 68. Don't make it up, right? You're going to take somebody from there, and you're going to show what it means. 2-1 means 21 years, and you have to put the units in. They are super fussy. I'm just going to pause. I'm going to just start the recording again. So the textbook doesn't ask you for mean, median, and mode for a while, but I want you starting to think about it. And it seems like most of you have some memory. So mode is the one that occurs most often. So looking at this particular stem and leaf, which number occurs the most often?
1.
No, there's no ones.
2s, 20s, 21.
21. Answer the question. Okay. So the mode over here is 21 years. Notice it's always the variable we're talking about. We're talking about people's ages. It has to be 21 years. It's not the fact that there are 3 of them. That's not the mode. The mode is that it's 21 years, right? So the mode is the one that occurs most often. It's 21 years. It's easy. The median, what does the median mean? What does median mean? It's the middle mark. So we use it the most often because it doesn't get skewed. So in other words, if we look at the salaries of somebody working for McDonald's, and most people are working, I don't know, $20 an hour or more or less around there, right? But the guy who owns the McDonald's franchise is getting, I don't know, $1,800 an hour. If we go and add in his salary, and you add it up with all the employees and you divide by the 10 employees, it's going to look like they're all earning a lot more than they're actually earning because his salary is going to skew it completely, right? That never happens with median. If we line you up and one of you turns out to be like a giant who's 9 feet tall, if we line you up and we look and see who's in the middle, it won't matter that we've got a 9 feet tall person on the one side because the middle will still be within the normal sort of range. So median doesn't skew. So median is good, and that's why we use it more often than we use mean. When you use mean and we add everything up and divide by, in this case, 6, then you can end up with skewed data. But I'll go through it in more detail as we go, right? I'm just getting you thinking in that respect. Stan? So we're going to look for the middle. So in order to find the median, the one thing we want to use is median position. Okay, this tells us where the median is, which is your question, Stan, but not what the median is. So one of the biggest mistakes young people make with this, usually by this age you guys don't make it, is instead of telling me what the median is, you tell me where it is. So do you agree with 6 of you sitting here, the median would be between the 3rd person and the 4th person? Do you agree? We'd have 3, median would be between the 3rd and the 4th. And if I asked you for median height, I'd ask the 3rd person, what is your height? And that person would say maybe 170 centimeters. And I'd ask the 4th person, what is your height? Let's pick an area, 166 centimeters. And then we'll add them together and divide by 2 and say the median is 168, right? But you won't say that the median is 3 centimeters. That is or 3.5 centimeters, right? So please don't lose your mind. So over here we've got 20 people. So the position of the median is 20 plus 1 divided by 2, which is obviously going to be the 10.5 person, right? But you're not going to say there's somebody who's 10.5 years old. Is the middle person here 10.5 years old? No. So that is the position. It tells you where it is. Now, I told my year 12s this many, many, many times, and they were told when they were in year 11, and it's still, I think they've got it now. You've got to be careful when you work this out. If you go from the lowest to the highest, you're not going to make a mistake. If you go from the highest to the lowest, I'll show you the mistake you can make. You need to avoid doing it. So going from the lowest to the highest, I'm looking for the 10.5 person. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So this person here is the 10th person, and this person here is the 11th person. Do you agree? So the median is there. So the median is 32, because remember that person is 32 years old, plus 35, and you're taking an average, so that's 67. And half of 67 is 33.5. That's the median. It's in years. It makes sense. It's a middle age in that distribution. If it's not an actual person, you take the average of the people on either side of them. Anything else? And I know that you understand mean. The mean, we add all of these up and we divide by 20, right? So I'd go back to the raw data. I would use this because there it is. If they give me the raw data, why am I going to use the stem and leaf diagram and maybe make a mistake? And if I made a mistake on my stem and leaf diagram, now I'm going to get my mean wrong, right? But if they gave you only a stem and leaf diagram, you'd say 14 plus 16 plus 17 plus 21 plus 21 plus 21, etc. Add them up, divide them by 20. Note, they almost always tell you how many people are involved. So you should check your stem and leaf diagram. If you have 19 things on there, then you've forgotten one and it's wrong and you're going to lose your marks. So you need to be careful, check that there's still 20. Okay. The mistake you can make is to do this. If you're going to go from the highest to the lowest, and they often give them to you with the highest on the top and the lowest on the bottom, right? So they usually give you a stem and leaf diagram upside down. It's the convention. Then you have to start here. I have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. In other words, I have to start from the highest. And what people do is they start from the lowest. They go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And now it's wrong. Now it's the average between 35 and 36, which is 35.5, and it's wrong. You have to work either from the smallest consistently, I'll show you what I mean, or from the tallest. So please note for your median, at 33.5 years, you don't round off. Median and mean are completely abstract. If your mean is 26.13, and they say round off to 3 significant figures, your answer is 26.13, because it's round off to 3 significant figures where necessary. And if it ends after 4 figures, it's not necessary. If your mean is 21.6315993317 and it fills up the thing, you round off to 3 significant figures, right? But we don't round off means to the nearest whole human ever, and we don't round off medians either, unless there's a good reason, like it fills up your whole calculator screen. They're abstract. They're allowed to be, if you've got 6.35 sheep as your mean, that's absolutely fine. Okay, here's a back-to-back stem and leaf. So please look at this. So they often make you make this. They make you make the same one diagram for 2 different groups. The groups they'll be more or less the same. It says here 10 students received coaching and 10 students who did not receive coaching took part in a mathematics competition. Their scores are shown in this back-to-back stem and leaf plot. So again, you'll see I cut off the key. I shouldn't have cut off the key. I'm going to just delete it and put a nice thing there. See that they've put a nice little key in there. So there's the key. It says 9-1 means, and notice how that they've shown it the way that it's written on the table. So they're doing this, they're saying 9-1, right, means 19, and they should say what it means. And it should be, it means a score of 19 for maths test. Please just be really thorough. And then over here, 1-5, which they're referring to that one, means a score of 15 for the maths test, right? Yeah.
Won't it always be like that? Like, how do they change it? Do you have to simplify it and like shove it in differently?
No, it will always be like that. So what they do is they give you raw data and they tell you to do it yourself, or they give you the thing and they ask you for the median, mean, mode, interquartile range. We'll do interquartile range later, not today, right? So they ask you to use it for information. Let's just do the mean and median and mode. Well, not the mean. We won't bother with the mean, but we'll do the median and the mode for the coached and the not coached, just to check that you know how to do it. So just do it yourselves quickly, and then I'll check that we're on the right track in a minute. Let me just pause. So the median and the not coached, starting at the smallest, 1, 2, 3, 4, 5, 6, between these two. So, and I haven't put the median is wrong because it's 16.5, isn't it? Anyway, I'll come back to that. I'll go back and fix this one. So this one is between the 5 and the 9, and so that's 15 and 19. So the median for the not coached is 17, right? Remember what they actually are. That's 15 and 19. And over here, 1, 2, 3, 4, 5, 6. It's there, which is 26.5.
Why is it 10 plus 1 divided by 2, the median?
It's always the size of the sample. If you think there's 6 of you, if I want to know where the middle is, I'm going to go 6 plus 1 is 7, divided by 2 is 3.5, and it will be exactly between the third and the fourth person.
Okay,
Yeah, try it for any number, it works for everything. Mode, there doesn't seem to be a mode. Is there a mode for either of them? There's no mode.
No.
And that is one of the big limitations of modes. They often aren't there. Or they're just useless. Imagine that two of you get 48% for a test, right? Does it mean that on average you've got 48% for a test? I mean, in the class, does it just because two of you have? So mode is only useful when lots of people have it. Okay, otherwise it's a waste of time. So last bit of theory, frequency polygons. Easy concept. It's a bar chart where someone has taken the midpoints and joined them together. So you literally take the midpoints. If they tell you the class starts at 10 and ends at 20, you go for the midpoint, which is 15. So you take the midpoint and you join it together, and it makes a line graph. So it has exactly the same advantages and disadvantages of the bar chart because it is a bar chart, right? And there you are. You can go like this. You can join it together and join that one together. And that's why it's called a frequency polygon, because it looks like a many-sided figure. Officially, one should actually join it to the end of the interval, although your syllabus just leaves it sort of hanging there in space, in which case it's not a frequency polygon, it's a line suspended in space. And there's a bit of a question whether you'd go down like this or whether you'd go down to the midpoint. But you can just go to the midpoint and stop because that's what your syllabus wants, which is nice and easy, right? So yours will hang in space. You'll go to the midpoint of each thing, join them up. There's one advantage that a line graph has over a bar chart, and that's if I want to use it to predict something. So say I wanted to see what is the frequency of somebody who is the height of 62, then I can come there and I can look across and I can say, oh, there'll be about 13 people who have a height of 62, which you cannot do with a bar chart, but you can do it because it's a bar. Where's 62?
Oh,
yeah. So that's more for biology. When they ask you what is the uses, why would you use it in biology? If you want to predict, you want a line. It's much easier, right? But it's just literally a bar chart where they've joined the midpoints together. Very straightforward. So hopefully that won't bother you.